day the 5th, I guess, and we are, as usual, testing our sound. So if you can hear us, just let us know in the chat. We are testing the sound on our side as well. Will be in 20 or 30 seconds.
Okay, hopefully everything is okay.
Yeah, the sound is well, so it works. So we are again here. Diane, we don't see you, but we hope you are with us. So hello everyone again. I am Bogdan Maheros, and we are having Data Community United for Ukraine today. So thank you for coming today. Today we have the 5th day of the conference marathon, taking 3 weeks, 9 amazing speakers all over the world, and we are talking about a lot of interesting technical things like business intelligence, Power BI, clouds, data science, and a lot of other very interesting technical things. But you know that not technical only. We are collecting funds for our Marine units who are our soldiers who are in hot places right now, and they need additional eyes. Our goal is the copter that costs $14.5 thousand dollars, and it's a bit expensive. So and we can afford it only with your help, and all donations are going directly into one of the biggest Ukrainian charity foundation, Come Back Alive, which in Ukrainian we say "Повернись живим." So even minimal donation is great help for our soldiers to be alive, to see the enemy, and come back home alive. So also don't forget to subscribe to our YouTube channel, where we basically stream. But beside that, you can watch us in Facebook, LinkedIn, Twitter, different social networks. But we are trying to do the best quality in YouTube. So anyway, thank you for coming today. And today we have 2 amazing speakers who will be presented by Taras Uzarkiv. Let me remove the banner so you can see us. Yeah, like that. So Taras will present our speakers. Taras is the lead data warehouse and business intelligence developer. So I guess you can remember him from SQL Saturdays that we have before the war, before COVID, and it was a great time for spending with friends, with colleagues, learning a lot of interesting info. So, and besides that, we have also Katalin and Diane, who are supporting us with their presence almost every session. Thank you for being with us. And Taras, your turn.
Wow, cool. So hi guys, this is really great audience. I really like to see you. And when you speak about the SQL Saturday and our event, I really miss this time. Yeah, I hope in the near future we'll see together on some real offline event. But anyway, so it's a pleasure to me to join this event, and just few words from myself. So I'm happy to see how data community support Ukraine. Yeah, and this is really great example to see how technology can unite people around the world, and especially our data community. So and I just want to say that for our audience that today our main goal to support our Ukrainian army and our current initiative. So our key goal to buy copter for our Marines unit, and keep supporting us, keep supporting Ukraine. Thank you. And today, as Bodan mentioned, we are going to have really fantastic presentation, I guess, because I saw them a lot from the André and from the Damian, and they together are going to discuss a lot of the interesting things. Just a few words about the so André Melancia. I want to say that food expert, tremendous engineer, and the human being, definitely. Thank you. Welcome, André.
Thank you very much. Glad to be here. And Taras, I haven't seen you well in person since 2019, so 3 years with the pandemic and everything. So we need to go there, and we need to wrap this up and actually have rebuild Ukraine, get things back to normal, and meet again, of course.
Yeah, we definitely will. By the way, in Lviv we have really nice new places, so we definitely need to try. And Damian Vaidera, I hope I spelled this right.
Yes,
so
all good.
I saw a lot of the presentation related to the sequel, and it was really deeply covered. I'm honored that you joined to us, and I know that you write one book. Unfortunately, this is on Polish. I didn't find the Ukrainian version, so maybe in the future we will have someone. So yeah, thank you to join, and I hope we'll enjoy this presentation. Welcome, guys.
Yes, thank you very much. Thank you, André, for inviting me here. So
okay, all good. So should I open the screen? I have stuff to say about you.
Yeah.
So anyway, let me just share my screen first. Okay. So screen 2, and what I'm actually going to do is, because it's mostly 2 people that will be here, this will have some difficulty for us to, how do I say, for us to talk at the same time. So when the video is being shared, I'm actually adding my own image here. Hopefully this is okay. And then when you speak, you'll actually show up on the right. So I show up on the left, you show up on the right. Please confirm that this is actually working. If not, that's okay. So
I hope so. It's working. So yep,
okay,
I'm still talking.
Okay, so 20 seconds.
Yeah, I see both pictures. I see both pictures. Yeah. So, but only when you are talking together.
Okay, so so hopefully this is okay for everything. Damien, you have to keep on talking pretty much. So I added this here because we cannot have 2 at the same time, and that is actually one of the reasons I'm very upset, because we just had a session together at 6 o'clock in the morning for Data Platform Virtual Summits, and I was actually looking for a photo of the 2 of us together. I ended up finding one that I put at the end of the slides for today, but you know, I have photos of the 2 of us together, but it's only in the middle of huge crowds. And I found only one where we were volunteering on SQL Day to actually, you know, prepare SQL Day, etc. So this was the only one where we are even remotely close in a photo. Everything else is one of those formal photos that you have to do. Okay, so we'll get into that. I'll mention that in a bit. So okay, so let's get started, and we always start the session a few minutes late, but this is okay. I'm Portuguese, you're Polish, a lot of Ukrainian people here, also some Slovenians here as well, and some Romanians also. So this is normal. Everyone is usually late, and if we're not late, it looks bad for us. So anyway, I also have my cat here, and my cat usually shows up here occasionally, and she is actually one of the beings that's, when all of the machines take over, like Skynet and things like that, the cats are the only ones that can save us from the machines. Because if you have a cat, you'll know that they'll chew all of the cords and things like that. This is expected, okay? So let's have a look. So this is me. So I do a few sessions altogether, and I've done quite a lot of sessions in Ukraine, of course. We'll get to Damien in a second. So I have stuff to say about you as well. And we of course have a session for Data Community United for Ukraine, and we want to help. We want to help with anything that Ukraine needs. Everyone in Europe, everyone in the world is solidary with Ukraine. We do try to help, and with that in mind, I invited Damien, and we also have here Dejan. We also have here Katalin, etc. And all of them have, in their own way, in their own country, like me, we've always tried to help. But you, Damien, and you and everyone in Poland, you had done an amazing job, doing a lot of helping with anyone, especially anyone coming in from Lviv to the border. So Agnieszka, Tomasz Libera, a lot of people who I cannot...
Marcin as well, yeah.
Marcin exactly was here yesterday, yeah.
Yes,
so
yesterday.
Everyone was helping a lot. So Damien, thank you very much for the amazing help that you and every other Polish person, especially the Polish data community, helped a lot. So many people from the Ukrainian technical communities as well. So thank you very much for that. And it was fitting that you'd be here. So you reached out to me yesterday, and I thought, well, you're doing a session with me for Data Platform Summit as a guest. Why not come here as well? So very fun. Okay, and so let's move on and let's talk about interesting things. So this is you. I got this from the internet. So some robot, some crazy Skynet robot, took a photo of you and identified you. You are Face ID 8D11, apparently, whatever that means. Okay, so we'll talk about robots taking over and machine learning days. And if you are a developer, if you are a DBA, if you are someone that handles data altogether, you need to know these kind of things. Okay, so nowadays machine learning is something that everyone should know about, right? And Damien, you have such experience. Let me just before this, let me just say you are welcome to ask questions or pitania. So anyone who has questions, please ask at any time. Someone here, we have so many amazing people joining us today in our panel. So anyone will help us with the stuff in the questions, and they will ask users at any time. So Damien, what do you think about machine learning?
Yep, it's from my perspective, it's the future, which should help us in, let's say, on daily basis, depending what we do. It should help us everywhere in some, let's say, things we have to do in real life. Could help us also in more advanced places like, let's say, medicine or solving tough problems, let's say, in general way. And yeah, the idea is that we should we would like to have our life better, right? Easier and better. So why not to give the machine something to do? So let machine do the boring stuff, and we as a people, we should have the, I would say, more stuff which is more interesting to do, right? So I think this is how it should go. But well, we'll see.
Okay, so let's have a look at what artificial intelligence and machine learning are. So the differences. So artificial intelligence is what most humans nowadays don't have. Some humans actually require a bit more intelligence. My cat is very intelligent, so I'm proud to say that she's more intelligent than some people we see nowadays that think that the Earth is flat. And we know that the Earth is not flat. It has to be cubed because we live in a three-dimensional world. But let's move on. So Damien, how would you describe artificial intelligence and machine learning?
Yep, I see beautiful definition here. So I'm thinking about the definition which we know, for example, from the, let's say, from the official courses, when the material says that first of all we have, for example, data science, where we have very smart people thinking about, let's say, how the world works, and they define all the algorithms and possible solutions. Then we have machine learning when we try to build models. But the AI, I would say it's like a software that should help us solving the problem. So that's how I see it in that case.
So let me put this in a way for developers. So if you are a developer, typically you get you feel afraid of machine learning and artificial intelligence. And in reality, we have Katalin here to confirm this as well, and also of course Dan. This in reality is actually not that difficult. So if you do artificial intelligence, it's just normal programming, okay? So you run a few lines of codes. The difference is that they have some more intelligence, some more magic in the middle, okay? That's the big difference, okay? But in the end, they will actually have some predictable codes, but the way that the codes looks at the information that they have, that's the real magic. That's why a car can self-drive, because they have information along the way, or even plan a route or something like that if you want to. But in reality, it's programmably predictable, okay? But what's not predictable is the data that you get on a regular basis, because that is very chaotic. So if you are a human driving on a road, you have no idea which cars are going to be next to you, etc. That's the chaotic part. But the programming itself should be very obvious, okay? It doesn't look like it in the real world, but it should be. But machine learning is very predictable, okay? So please go ahead. Please go ahead.
Yeah, exactly. It should be predictable, right? We'd like to make predictions based on this. So that's the idea. We'd like to know how the tough part. Maybe we don't like to get into the details, which, for example, Dejan could explain us as great mathematicians. So Dejan could explain all the algorithms. But let's say regular people like developers like me and you, we maybe are not that interested into the tough details. We'd like to know how to use it. It should be pretty easy. And we'd like to know what this model, what the machine learning actually can solve for us, what kind of problems we can solve in an easy way.
Mm-hmm. Perfect. One of the things I usually say is that when you do machine learning, assuming you have the same input, let's say it's a table, it can be an image or something like that, but it could be a table. If you have an input data, in that case, when you run multiple machine learning trainings on the data, assuming that you use the same algorithm, same hyperparameters, etc., same configuration, the result is usually going to be the same. It doesn't have to be exactly the same, but statistically, it's going to be plus or minus 1% difference in terms of quality, right? The reason why sometimes this is different, and if you think of it from a programmer's point of view, well, I ran some codes, it was the same input, I should get the same output, right? In theory, yes, but machine learning uses a few things that are uncertain. So for instance, in machine learning training, sometimes you define, oh, you run this as much times as you can, so many iterations as you can for 30 minutes or for 30 hours or whatever, right? So depending on how your CPU is running, it might give you more or less capacity for just a few milliseconds, and that can make a difference between getting a better result and a worse result. But it's going to be 1% difference, okay? So it's statistically irrelevant, okay? So you can think of artificial intelligence based on the inputs of artificial intelligence to be chaotic and erratic, but internally it should be predictable. And machine learning, what you have for inputs and then outputs should be fully predictable and fully kind of deterministic, okay, although not 100%, but as much deterministic as possible. And with that in mind, most of the people watching will probably be using machine learning within 5 years, if not just right now, okay? Because if you go to a university, most universities now actually talk about machine learning. And here in Portugal, we have universities where we talk about machine learning, and they are not even engineering universities, okay? We have machine learning for things like economics, like management and finance, etc. We have economics for any area that uses numbers, biology, etc. Why? Because this goes into every field of knowledge, and you need to have that. People using, I don't know, 20 years ago, people used Mathematica and MATLAB and things like that. Maybe they did something simple with that, but every person in a lot of different fields of study in universities, you would use that. And maybe they just did basic programming at the time, but nowadays you can do machine learning with the data that you have. And here's the part that's important. You don't need to know what's inside, as Damien mentioned. And Dan probably knows some of this, but I don't, as I'm a developer myself. What I can do is that I have a black box, I have my inputs, and I expect some outputs, okay? This is not my problem anymore. What's inside the box? Well, it doesn't work well. Oh, it's Microsoft's fault. Problem solved, move on, right? So it's always like this. You blame someone else, problem solved, but it's a black box, should work, okay? So let's have a look at some algorithms, but before let's mention a few things. By the way, I do apologize for this, but Damien is in the corner. You do have some space there to have his image there, but my image, because it fills with some of the algorithms, I'm trying to move myself around so I don't bother the slides. Sorry about that. It's not the first time, but at least it's practical to do it like this. But anyway, two types of algorithms. So we have supervised and unsupervised. Damien, do you want to explain?
Yep, supervised machine learning, we have the idea that we know how the data looks like, right? We have the input data and we know what is the output. So we can make a description about the process. We can describe what is the input, each of the property or column, and we know what is the output. For example, it could be, as we see on the slide, there are, let's say, two types of the supervised machine learning, classification and regression. So in terms of classification, you can say, okay, is it black or is it white, right? So I know the output perfectly based on the input of the data, which might be, at the first glance, it could look like a very good solution for every problem, but as we probably will mention in a moment, it's not always this way, and unsupervised machine learning will help us in many other cases. Yeah, but maybe we can describe what the linear regression is where it fits, and what we can do in terms of classification, right? How this works.
Exactly. So just for the unsupervised, let me just mention one of the things that we are being used with unsupervised, especially the imaging one, and specifically using neural networks as a technology to handle these algorithms. So right here, I am here. So if I cover myself, suddenly you see my kitchen, right? Because I'm using some virtual background kind of option. And if I put my hand in front of my face, suddenly you see my kitchen, which is not expected, okay? Damien is using a different one, which comes from Zoom. I'm using one that does not, which is very specific to my computer. So this has different handlings. If you use Microsoft Teams, the quality is much better when you have a virtual screen, but you get the idea. So we'll have a look at some of this. And by the way, Diana is here and Catalina are here. We'll ask them questions as well, because they are experts, each of them in their own area. Catalina is an expert in cats, hence the name Catalin. So we'll talk about some things with them as well. Okay, so yesterday Catalina was at the vet's, with or without the cat, I'm not sure. So anyway, let me get rid of this. Let me get out of here. So Damien, you are probably here, visibly here, but let me just mention what's here. So here on top, I have some CSV file. It can be a data set, a table, whatever you want to do. Okay, and just here at the top, I'm actually processing the data, so the same as clean here. So cleaning up the data, etc. So let's go into each of these things. And by the way, some of the examples we have here, these are not all. These are just like a small subset, like the previous slide, like a small subset of everything that's possible. Just a few examples. Okay. So Damien, getting the data sets does require you to have some good quality data from start, right? So if not, machine learning will be awful.
Of course, in every process when we deal with data, we'd like to have the input data in a correct format. It should be clean, but we know that the real world is not working this way. That's why the first step when we get our data set, we need to perform so-called data engineering, which is beautifully explained in point number 2. So we have the cleaning, we have some kind of preparation, maybe data transformation, and we also include this feature engineering stuff, which can be more or less complex on a technical way. One of the operation could be that we'd like to find out if we maybe try to reduce the number of inputs, try to keep them small. Because if we have smaller inputs, then maybe the model will be also simpler, not that complex. And I think it's a beautiful slide. You have it when the model is too complex, so it might not be working very well. So, for example, we can perform a let me say it this way, we can perform a step which is called PCA, which allows you to make the model less complex. For example, instead of having, for example, 11 or 12 or 100 inputs, we can reduce them into 2 or 3. In that case, we are able even to visualize the inputs on the screen and how the model behaves. So those types of techniques. I know that it looks very dangerous for developers, but it's not, because we will be using great libraries. So again, the complexity will be hidden. We just need to know what library to use, and that's the magic here, I think. Right.
Exactly. So just for reference, the stuff that you see on the right, so all of the diagram that you see on the right, this is actually taken from the designer, the graphical designer that you have on Azure Machine Learning. It could be a different thing. So there's a lot of products that do similar things like this, but you can also do this with code. So yesterday we had a look at Marcin's session. He was doing mostly code stuff. So we'll have a look at this. We'll do some demos of this in a bit. Okay. So anyway, let's bring up the next part. So the next part, it is actually very typical. Once you clean up all of your data and normalize it, etc., sometimes you need to guarantee that the inputs from person A, person B, person C, they all fall into the same scale, the same logic, a lot of things. It is actually very typical for machine learning to have values that are transformed of two values between 0 and 1, because the machine understands them better. Okay, we understand the exact opposite, but machines understand between 0 and 1 better if they're decimal. So it's a thing. So anyway, once you get here to splitting the data, why do you split the data? This is strange, isn't it? So Damien, would you like to explain why we split the data left and right?
So first of all, we have a data set. Our data that comes to the system, we'd like to use part of the data to create the model, and then the other part of the data to test the model, whether the model has a good quality or bad quality. So the idea is that the testing data, it should be the data that the model has not seen yet. That's one of the ideas we can have. It's not always working this way, but of course, it's one of the best practice. So we have to split the data in a proper way, of course, to make sure that a part of this data will be used for training and the other part will be used for testing, right? And then we can perform scoring, check how the model behaves for the data it has never seen.
Okay, so we seem to have a question. So
waiting for the question.
Yep. Yeah, the question is about the cross-validation and the divided into 20 to 80 or 25 to 75, right? So maybe here is a good chance to highlight the difference and in what cases it's better to use the cross-validation and when the 75 to let's say 80 to 20, right? To simplify things.
That is a really good question. Damien, do you want to take that?
So the idea is that sometimes you don't have the testing data set and you have only the input data set as a whole. You don't know how to split it or don't want to split it. So in that case, you can perform iteration. You can perform the learning in iterations. So the cross-validation means that you are, for example, dividing the data set into, let's say, 5 elements. So one of the elements will be used for testing, 4 of them for training, and then you perform the second iteration and you take the element which was used for testing, you move it to the training part, and you bring the one from training and you move it to testing. So if you divided the elements, the data set into 5 parts, then you have to perform 5 iterations. And then you were talking about this split 70 to 30, 75 to 25. It's a rule of thumb that you should use around 70% of your data for training and what's left on testing. But if I ask you a question, if you have 10 millions or 100 millions of, let's say, data samples, is it right split to use 70% of them into training and 20 or 30% for testing. And you can say, okay, if I have 1 million of rows, then maybe I can just train on 10% and use everything else for testing. Because from statistical point of view, if you have million of rows, it should statistically model the process which is inside the model you would like to create. So there are different approaches depending of the situation. So let's say the best practice says 70 to 30, but then you can have a special case, and you can say, okay, maybe 10% for training is right enough, and everything else for testing. Because I would rather say I'd like to test more my model on the data the model has not seen to make sure that the model has a good quality in that case.
Perfect. So just let me add one thing which complements what you just said. When we are splitting data, one of the things that you can do, let's say it's the 80, 20, 70, 30, whatever the value is, one of the things that's very typical is for you not to split the data directly. You split randomly, so you don't specify the exact one part and the other part. It's random, and that random is yet another reason why sometimes your training shows up with 1% more, 1% less, whatever the metric is going to be, right? So that is actually one of the reasons. But if your data is good, that shouldn't oscillate the problem. If you randomize the inputs, it shouldn't be that much of a problem. Okay. So
if
anyway,
I can add one thing here, because I'm always asked about this split part by the student. So the student asked this have a question like this: how should I do the split? And I tell them in a way like this: you know that if we have data, the data follows some statistical distribution, right? Everything around us should follow the normal distribution. Of course, we can have different statistics, but if we imagine a regular process, so we know how the normal data distribution looks like. So you should split data this way that your training part and testing part also follow the same statistics. So for example, you cannot take 20% of the data, let's say, from the left part of the data source or data set, and 80% for training from the right, because then the testing part will be done on the data which is not recognized by the model. That's why you have to do it properly. Hence, you should use the libraries, right, which can do the split for us properly, so we don't have to care how they do it.
Okay, just on that, let me add one thing. I really don't want us to go into this because we would spend here all day, but there is something called responsible AI, which nowadays is a thing, and it should be, that guarantees that when you split your data, there's some level of fairness. There's other situations for responsible AI, guaranteeing that it doesn't discriminate people given, I don't know, a nationality or a situation or whatever the situation is. And that is actually very important. Okay, so we don't want to talk about this. So today we'll talk about the technical stuff, but have a look at responsible AI. There's a lot of websites with that kind of information. Microsoft, if you go to microsoft.com/something responsible AI, something like that, you have an address to actually have a look with actual examples. So please do that, but we will just talk about the technical part. That's more, that's also interesting for anyone implementing this, but less for the session today. So Damien, if that's okay, maybe if Dan is here, we'll actually suggest Dan to talk to us about the training, if Dan is here.
I would love to hear Dan because of his deep knowledge.
I'm here. So what do you want to talk about?
So Dan, we are up to the training part. Can you tell us about just a normal training or a hyperparameter training? So what's the difference between the two?
Okay, so this is specific terminology that we use in general in data science or machine learning. So training means you apply algorithm on your data, on your training set. And if you look from the algorithm perspective, the training set is actually a parameter. So then the parameters of the algorithm itself are then what is called hyperparameters. So for example, let's say that you have decision trees who are splitting data into subgroups, more and more. Typical hyperparameter is controlling how many levels do you want to have. For example, you say, I will stop splitting when the number of cases after the split in any of the groups would be less than 100. Let's say this 100 would then be a hyperparameter. So the parameter of the algorithm itself when the data is the first parameter.
Okay, perfect. So and just to mention, so with hyperparameters, it is very typical to run multiple hyperparameter trainings. We have Azure ML that has an amazing SDK that allows you to run this all in parallel. You run like 2 or 3 lines of codes and everything works. So this is all very amazing. We'll have a look at that. Next up, after the training, and by the way, all of these algorithms that we are talking about, we will talk about more about them just in a second. We will have everyone talk about their own favorite one. So let's see. I'm not sure what it is, but we will talk about this in a bit. But next up, we have scoring and testing, and maybe we'll talk to Katalin, who is our biggest consumer. Clean should be in all caps. Okay, yeah, someone is saying from the comments, clean should be in all caps and bias in AI is inevitable. That is all true. I completely agree. Just like bias in humans is inevitable, responsible AI is about understanding the bias in models, where it comes from, and how to address it. Yes, it is. I completely agree. So, Katalin, are you there?
No, I'm not there.
Okay, so you are handling cat issues. So Katalin, when you have your IoT devices and you need to do some predictions based on some model that you've trained already, you can actually put all of that in your devices. Let's see if I can do this. So I have, like, let's say a Raspberry Pi or some other device that you can use. How do you do this? Can you use Azure ML? Can you use other technologies? What do you usually do?
Well, let's say the very low-hanging fruit is using cognitive services and Azure Percept, because it goes everything by click. With the devices, there is, let's say, an additional level of easiness / complexity. We can do the inference, especially in custom vision, means the recognizing, running the model against the images. You can do it in specialized hardware, which could look like a stick, or it could be baked in, even in your camera. So yeah, you need to move the model to the device and then run it, and then you get the results. I'll say the lowest hanging fruit is using cognitive services in Azure Percept, just a click. Yeah, it literally is just a click. You say, if you train your model in cognitive services, you go to Azure Percept Studio and say, deploy that model. And the model is deployed, and you will start running. Of course, you can do it also the hard way. You can get any model. Also depends on the hardware, because the hardware that does inference, usually there are 2 big players. It's Intel, and it's NVIDIA. Both the pluses and minuses won't hedge badges. Bets who will win. But they have their way of running the models on these parts of hardware. Microsoft helps on this, because sometimes it's often the blows of developing around. And you can run it on this hardware. And you have shown a Raspberry Pi. You can run it even on Raspberry Pi without any additional hardware. And you find a lot on the net, but it's far from powerful. I would say hardware will get the performance up to 100 times or more. Specialized hardware, especially to very, very low level, entry level, like it's Raspberry Pi or something.
Okay, so just to mention one thing. So let's say you have a Raspberry Pi. The inference, you mentioned a very scary words, because if you are just getting started now, you have to learn some strange words, and inference is one of them. So Inference is just doing predictions, okay? It's not complicated. Like feature engineering is just feature is a column, it's a fields. So feature engineering is playing around with fields, okay? So let's keep it simple for everyone to understand, because when I started to learn about these things, I'm like, why don't they just call them fields? Okay, yes, so there's long story. We also have this for dimensions,
I would say
measures in BI and things like that. Let's not go there.
You get the image, the hardware will get you what it gets. It gets you what you recognize, the label, the confidence, and the bounding box. And that you get formatted as JSON. This is the process which I named vary. And this is done, best should be done by hardware. There are specialized processors that doing this on the and also on sound.
So, Katalin, one of the things that's you use a lot, and I've seen you demo this, is that when you have an IoT device, you usually deploy things. So, Azure Machine Learning is an example. You actually have a container, which is basically a module or a container that you add to Azure IoT Edge that has that model. The model is basically one or more files that you take out of the training. So that very small model, and here's the irony: if you start with a training with 1 petabyte of data, it might take you weeks or even months to process the whole thing. That's fine. But in the end, you might end up with a very small distilled amount of data, which can be just a few kilobytes, okay? So you're fine-tuning everything. We'll see a few examples. We'll fine-tune everything, and then you can put that in an IoT device, in a cell phone, or something like that. So from your point of view, you want to get the result out. That's the magic. You want to get the result out.
Also, want to get the performance. Intel has a whole theory that they want to take the model and optimize the model to the processor, because some of the a model, there are some number which are the weights. Some processors, they do not understand floats, or they understand some kind of integers, so that they want even to do that optimization. Not that much for the size of the model, because the size of the model will be still decent in hundreds of megabytes. But to do it faster on the processor at hand, because the real goal is I'm in the custom vision, even though I do not need it. The goal there is to recognize almost instantly. Like I'm looking at this image, I read everything which is on my screen instantly, almost instantly, not wait.
Okay, so let's move on, and Damien, let's talk about evaluating those models. So what kind of things do we usually do? What's that?
So we would like to know, let's say, what is the quality of the model, right? So we know we have a metrics and information how the model behaves on the training data. We have information how the model behaves on the testing data. So we would like to know the metrics and say what is the overall accuracy of the model. So at the end, based on this information, we'd like to say whether the model is good enough for the problem to solve the problem we have. Because the entire idea of machine learning is that at the beginning we have to have a good defined question or problem we'd like to solve, and we have to say what is the, let's say, maximum error we can have on the questions. So I can say with 95% of probability, tell me whether I am sick or I'm healthy, right? So I know that I have 5% of uncertainty or error. So my model has to have the error below 5%, so it could be accepted. So in that case, it could be like 96% of good quality. I'm not saying what the metrics are. I'm trying not to use the technical words here, but 96% of good quality, so we can accept the model, which is also important because to achieve 99% of good quality might lead to very long time to train the model. It could be twice as much or even more. So we should stop. We should stop training the model when the quality is just enough, right? We should not go to 100%. Because 100% of quality can lead us to something, to very, very bad performance in a real life of such model. And from technically speaking, we can have memorization problems. So the model just memorize all the, let's say, information and cannot learn and cannot give us good prediction. So it's that kind of problem. So yeah, this is why we need to evaluate the model at the end to make sure that we can use it. We can accept it to be a good model before we actually, let's say this way, publish it to the production. And I'm not saying as a web service here, because that's one of the options. We can also deploy it to a container and make it available through a container, so we can scale it beautifully in the cloud. So yeah, but it's not end of the story at the end, because the last point is very important, right?
Exactly. So let me just mention this, because step number 4 and step number 6 are actually similar in terms of functionality. Not so much, but you pretty much do the same. You do predictions on both. But on number 4, you do that for testing, to in the end be able to evaluate your model with that quality that you mentioned. And 90% is already very good, and then it's exponentially big in terms of time, like you mentioned, to actually get better numbers. So it's crazy. But when you go to step number 6, that's the story when you have things for, like Katalin deploys things into an IoT device, etc. That is actually the normal thing. So it's typical to have a web service. It's typical to put this into your own application, or a mobile application, or website if you want to. So it's easy. The retrain back is scary, because you think, when do you retrain? So maybe we'll ask Dan for that. When do you retrain? How often? What's the rule? What's not the rule? Any ideas?
It's not that easy that you would just say, I will retrain every week or every month. The point here is that you have to measure the quality of predictions over time. So of course you have to store them, let's say, in a kind of data warehouse at the actual values. And then when you see that the quality of predictions deteriorates, apparently there is time to do something. Also, you might also notice some data drift. You might also notice some data drift. So for example, after some time, you might have more, let's say, highly educated people than you had in the beginning. And you might also decide to do retraining based on this data drift. But it's never so easy to just, I wouldn't say just do it once per month or once per week.
So one of the, if I can say a practical example, in Poland we have a network of stores, smaller stores, which you can find in every city and every village. So they actually train the model almost on daily basis. This is how they do, because they do a lot of, let's say, product changes, and they would like to know how this works. So I was talking to their development team, and they told me, yeah, we train almost every day.
Okay. So a lot of different companies that used AI to do prediction on, I don't know, products, something like that, before the pandemic, they had some expectations. As soon as the pandemic hit and everyone was doing different things that they did before, the world all changed. They had to retrain everything again. But the problem is, by that time, they didn't have the data to retrain, because it was only, I don't know, a few days, a few weeks that elapsed. So what do you trust? You trust 10 years of data, or do you trust 10 days of data, which are probably more correct than the last 10 years. So during that time, this was very, very much impossible. Nowadays, things are getting back to normal. But even because of that human scenario, like Dan mentioned, a technical term, which is data drift. So in this case, you have natural data drift, like the stuff that happens over the years, natural evolution of man and things like that, those kind of things. But this one is a natural evolution because of some scenario. we're here because of the Ukraine, and the Ukraine had the exact same thing. So a lot of changes happened there as well. 2 years ago, because of the pandemic, also other changes. So this, in terms of timing, this was a trick question they asked Diane, but there is no correct answer in terms of timing. It can be anything, like you mentioned, for 1 day, which seems very small actually, to, I don't know, 6 months, 1 year, or maybe it's so stable that you can just do one training and that's it. But that is a bit more rare, I suppose. So let's go to the next one. You can automate this, by the way. I don't want to mean that you have to do this manually. You can automate that kind of thing. So this one is actually nice. So let me put myself here in the middle of the cow. Poor thing. No, I'm kidding. So this is an example of when you have computer vision gone bad. So this is fully correct from a computer's point of view. You have a cow, you have an obstacle in the middle. This seems like a legitimate cow. There's an obstacle. So this seems legitimate. The problem is that the information system does not realize that the cow can be 5 meters in length or should be less, right? So some proportion. Now, when you train a model, this can be acceptable to understand that the model can have obstacles in the front and still recognize it. But yeah, there's something wrong with this. So you need to fix some limits, etc. Let's not go into details. This is just a funny slide so we can relax a bit from the other big one. but in any case, this actually happens. Okay, this kind of thing actually happens. Okay, so let's talk about this one. And this is on me. Okay, so let's say that you are in high school, and when you are in high school, typically you learn how to do this. Someone gives you a whole bunch of points, and they say, "Oh, draw a line that closely resembles the best way to map the points, etc." And there is a mathematical definition for this: the ones that get you the smallest error between them, whatever, right? Doesn't really matter. But in the end, a formula for a line, and this is just something called linear regression. This is just a line, and this line actually has a simple formula called A, which is this number from 0 all the way up to 20, I don't know, 26, 27, and then Bx, in which the B is going to be the inclination of that curve, okay, or the other way around if you prefer, it doesn't matter. So when you are predicting something, this line was what came out of this training. And the mathematical formula to do this is very simple. You get averages and stuff, and you work this out. It's very basic high school level, okay? And what's your model in the result? A and B, right? So you have a very simple formula to calculate this. You have A and B. Most of the other ones I'm going to show you next for regression are going to be polynomial, so much more complex, other techniques, etc. So those are going to be crazy to understand. This one is the only one I expect anyone who knows the basic programming to actually say, yes, I can finally understand how one algorithm works inside. This is the only one I can understand. Everything else is just a black box, okay? So this one you're expected to know. If you've been to high school, 12 years old, you should know this, right? A plus bx.
There is how you, because the question is, take a look at the data, which is in the yellow. To me, it's yellow color, but it could be a little bit different. So I cannot see colors very well.
Yellow, yellow.
Yellow. So we have a bunch of data, and the question is how to find the best line, right? That fits to the data. Technically speaking, it could be infinite number of lines here. So the model has to choose the best one. And the criteria is, as you said, to minimize the error. So the funny part is to minimize the error. And this is where the mathematics comes to play, because the error minimization can be, so this formula can be complex. Of course, not in this example, but that's the idea, how the model chooses the best solution. In our case, it has A and B as the coefficients, and we can use them then for predictions in our data, right? And yes, that's the simplest model we have.
So just to mention that what you're seeing is something very basic called linear regression. And again, right, that's probably the only one that you can understand how the model works inside. But for all of the other ones, this will be very, very complex. But there is other types of regression. So if we are going for the category of regression in general, because technically you can use regression as a method, not as a category, let's call it like that. Regression is the area in which you get a value, which is a continuous value. So you get a number, like a decimal number. So if I start with 70 here, I go all the way up to this, and then go down and I get 60. So you calculate the formula of A and B. So it's A plus 70 times b, and that gives you 60, right? So you can actually calculate, but this is a number. Whether the formula is like this or a big line or whatever the formula is, it's a continuous number. It's a continuous line. So you can get a value that's continuous. Next up, we'll talk about classification. This was mentioned before in the slides, but classification is like things like A, B, C, or D. So it's actually a discrete individual class, okay? So we'll talk about this later, but you can actually detect a lot of things. Biology is probably an example of this. So how things grow, how things not grow, etc. Weather,
weather is crazy complex.
It's crazy complex.
Because it's non-linear, yeah, in its nature, so.
So I usually say that you can predict the weather, that you can take the information for the last 100 years and try to predict what's to expect today on average. And there's a lot of websites that actually have, 33 days in the last 50 years, 33 of those, this rained or not rained, etc. This can help a bit, but in reality, the weather, by definition of weather, you can make some simple calculations like this, maybe with a curve, but to actually calculate the weather using all variables, it's so bad that it becomes chaotic in less than 7 days. It's impossible to predict in more than 7 days. You don't have computational capacity for this. It's too many variables, okay? It's the same way when you have planets, like 3 orbiting planets and things like that, with bodies. You think this is very simple, but it's not.
It's not.
Yeah, it's an unsolved mathematical situation. Unsolved, well, complex anyway. Kind of unsolved. So anyway, you can have a lot of things like trends, etc. So some of them might be okay, but there are better ways to do some of these things. Now, let me give you some more examples. Let me get out of the way. So this one is in a curve format, and we can tell that this is reasonable, okay? The next one, and let me go here, the next one is polynomial. So this one, you can see that the machine learning is doing its thing. So trying to find a formula to justify this. So the model will reflect the formula of that polynomial, okay? And remember that this can be more simple or more complex. We don't know, okay? So anyway, next up, we have multidimensional. It's a thing. Let's not go into details. This is just crazy, but yes, you can have more than 2 dimensions or 1 dimension inputs. This can happen, okay? Okay, so more things. Let's talk about bias. Damien, would you like to take the top 2?
Yep. So we have, if you see the data on the left, so we can see a lot of blue points, blue dots. So the question is, what is the best model that can fit here, right? So we can do a straight line like the red one here, but then you can see that the error will be bigger, and you should create a model which is a little bit more complex, but not complex that much. And what I mean by this, the huge complexity would be if you take all the dots and you connect them with one line. So the complexity of the model would give you higher order of polynomials, like the one on the right, you can see overfitted already. So the complexity of the polynomial, we can say it's like, for example, 7th or 8th or maybe 10th order of the polynomial. And we know that such process just cannot exist in the nature most of the time. It's just too complex. Our world which surrounds us usually is not that complex. So we should maybe use something which is in the middle. So the polynomial of the 2nd or maybe 3rd order, we should be able to explain this, how it works. But on the other hand, maybe we should not use just a straight line with 2 coefficients A and B, because it still creates a lot of error. And now take a look what we see. On the left picture, when we have underfitted, the error is very high. On the right-hand side, we have a polynomial. Let's say we have polynomial which introduces almost 0 error. So the 0 error means that something might be wrong here, because the model is very, very complex. And the question is this model able to follow the data it has not seen yet? So probably not. So the model which is overfitted will not work on the testing data. And probably the one which is in the middle will work just right for you. So this is how I can explain, not talking about technicality there. So
So just to give one other example, so let's say that you have a dot that shows up here, where I have my mouse at this moment. So that line is terrible, as we know. If we get the dot here, you're not going to get close to that line, so it's going to be terrible. But if you get it here, it's probably going to be closer to the line. Okay, so maybe this is not the best example, but the idea here is that even if you have a dot in the middle where I have the mouse right now, that would be a perfect line for the one in the middle. And this makes sense for us visually, but for a computer, this will go completely around it just to avoid it because the data was very specific and you ran very specific training. Okay, so yes, we can do a lot of this. So next up we have something which is a datasaurus. So this is scary. So we were looking graphically at the one before, and now let's have a look at graphically at this one. This red line that you see here is round numbers, and round numbers, that means that I was the one who drew it, so take it from me. So it's probably very incorrect mathematically, but
yeah, it's not correct mathematically. It's not correct.
That's okay. That's okay. But this is, let's assume that this is the average of the dinosaur. Okay. So the average we've seen some dinosaurs where this is slightly different, and the average of the dinosaur is actually a line, like a straight line. Okay. So the idea here is that you might have a lot of dots up and down, up and down, up and down, and this might feel like they draw something, that they have some different reality. But if you do the average of some data, suddenly it's a completely different thing. So you have to analyze the data in a lot of ways. And whenever I mention this, I always mention one thing, which is when you have your data, you cannot be a generic data scientist. Let's call it like this, okay? If you are a developer, you are developing for your own problem, okay? If you are a data scientist and if you go to a company that says, oh, we would like to solve this problem, we have this data. And if they tell you something like, oh, I don't care what the scenario is, just give me the data, we'll process it. No, you have to understand the reality of the data. You need to know what the data comes from. You need to understand the business. And this is very, very important, okay? It's like the mafia. You need to understand the business. So if you don't understand the business, you don't work, okay? Because when you get to see the data, you get some results and they feel okay. But in reality, they might not correspond to anything that makes sense in the business, okay? So anyway, we have some comments here. Let me just finish the comments from here and then we'll move on. Maybe get Dan to talk about the next one. So comments from, okay, I'm not going to mention names for privacy reasons. Sooner or later, more training time will not result in better predictions. Yes, salespeople often forget this thought. Yes, this is true. And then Catalina is talking about changing the mic. And people are asking what the mic is. I'm assuming it's the microphone, but if it's an actual person, please don't change the mic. We like the person mic, so please don't change it. We're not robots. We like people. Okay, so let's move on. Anyway, let me get rid of this. So we have an algorithm here, which in this case, it's logistic regression, but the slide is actually supposed to be more generic for all types of regression, okay, for all types of, classification. And then again, the name regression here is complicated because you're actually doing classification when, and you're using some techniques of regression. This is difficult, but maybe Dan can shed some light on the subject.
Well, logistic regression means you are applying what is called logistic function on your combined input variable values to get a single non-linearly transformed value, and then you call this value prediction. This is basically what logistic regression does. You know, applying, so you have multiple inputs, numerical inputs on the same scale. You combine them with the weighted sum in a single value, and then you apply the logistic, also called sigmoid function, on this value, and you get the output between 0 and 1. And you say, okay, what is greater than 0.5? I call this 1 or true or whatever. And what is lower, I call this 0.
Perfect. So Dan, would you like to talk about if it is slightly different, like a multi-class model? I don't have a slide for that, but...
you mean like multi-class, like you have multiple inputs, right?
No, multiple outputs, like result ABCD.
Okay, Typically, then then you can have different scales for the output, and you scale it like recode the value into the 4 classes. You can create separate variables, dichotomous variables or dummies that has like state D true false, and try to predict those instead, and make it let's say slightly more clear. And probably even if I have multiple the possible values for the target variable, I would even prefer to go to some different algorithm that I could understand better than logistic regression. Definitely decision trees would be more appropriate for this kind of a problem.
Okay, so we'll get into that. So we'll talk about decision trees in a bit. I have some of those techniques that we can use inside some algorithms because you can use decision trees and also other things, even regression, as you see there, and many other techniques. Things like deep learning, neural networks, you can use that inside of some of these different types of algorithms. So we'll get into that just in a second. But for now, and let's say the usual thing. So if you torture someone long enough, they will confess. And if you've been in any kind of relationship, you know that this is true, especially if you have kids, no matter how they try. I don't, I have a cat, it's easier. But if they try, they will insist until they get their way. So things are always false. The world is false until they insist that it is true. And suddenly it has to be true because, you know, it's complicated. Okay. So anyway, clustering. Damien, would you like to bring this up?
Yes, so this is an example of unsupervised machine learning. So we actually have a data set, and we cannot say what is the input and what is the output here. We cannot label the, let's say, the columns. We don't know what it could be. So I would say the idea here is that we'd like to, based on similarity of the data, right? So how similar you are to the group, which in mathematically speaking should be how far the data point is from the center of the group. So that means that it will be similar to one of the group and in a more way, and less similar to the other way. And an example of practical example can be here, like imagine you were in the cinema. Let's say you've seen like a James Bond movie. So next time, or you watch it on Netflix, so you will see a lot of recommendations because you like James Bond. So maybe you would like the other movie as well, right? So it's like a profile, and how much the profile is similar to a group. And you have other patterns here, which Andy specified, like shopping trends, so which we see every day. If you open a website and you, for example, looking for a new watch, so for the next month you will see advertisement. Oh, maybe you will buy another watch or something like this. This is how those algorithm works basically, which I think, yeah.
So if you are a prankster, the best way you can do is, if you see someone's computer open, just go there and search for some product that you know that person hates. Search for it like 3 or 4 times, and then that person will receive advertising for that product for like 2 months or something like that. So do it. It's a good prank. Definitely do it. Okay. Just to mention that the algorithm that you use to do clustering, this one, most of clustering is done with a single algorithm called k-means, and that algorithm is older than me and Damien.
Yeah,
and
all together. Yep.
Yeah, 1970s. I'm not sure when, but it's older than me. That's all I need to know. So anyway, a few examples of clustering with k-means. So you start with something and you end up with this. So the trick is, you actually, let's say you select three clusters here. So you select 3 centroids or centers, just dots, whatever. You select 3 randomly, and then you start to move all of these to find the closest place to them compared to that center. And then you classify them as being let's say a different color or a different number or whatever, and then they move around. So the center moves around to actually be the average of all of the points, and then it moves around a lot of iterations until it finds stability, and then you have the best algorithm, the best results possible based on that algorithm. At some point in time, this will stop. It can be longer or shorter, but at some point it will stop, okay? So I don't have any animation for this, but if you search online for k-means, you'll see a lot of animations in which the colors change from one place to the other gradually until they find the final resting point for the centroids here. And that will guarantee that all of the points are as close as possible to each centroids, but that they are the most optimized way to divide all of this, okay? For these three, this is easy. For these three, this is a bit more debatable, of course, right? So it might be different. Okay, so of course, Dan was talking about decision trees, and we have a decision tree for cats, dogs, etc. So I'm going to quickly give the example, and then Dan will take over. So let's say you have a cat, and this decision tree is already memorized. You start from zero, of course, but this is already memorized by the computer, and the computer needs to learn a bit more. So let's say next up we have a cat. Is it a mammal? Yes. Do people use it as pets? Yes. So the computer tells you you have a hamster. Oh, okay. Well, 4 legs anyway, tail. So next up, you have to decide what to do. And you say the computer, no, this is false. And the computer asks, what's the difference? And then you say, well, obviously we are doing this dynamically, but the algorithm does this automatically, of course. So they replace the hamster here with a question: does the thing meow? Yes or no? And then if it's a yes, it's a cat. If it's a no, it's a hamster. Okay, and then you move on to the next step, which is you get a dog. Okay, a really, really ugly dog, because cats are nice, dogs are ugly. No, I'm kidding. I like dogs as well. So is it a mammal? Do people use it as pet? Yes. So does it meow? No.
I'm laughing about Dejan's comment here. So.
Yeah, we cannot say this out loud.
Yeah, we cannot.
But that's a very
good example of decision tree here. Thanks,
this is a good example of decision tree. So people will see this video and figure out, what did he say? What did he say? You'll be asked this in conferences in the future.
Yes.
And this is a guarantee. Ask them for beers and stuff like that, so that you can tell them. Anyway, when you have that question, does it meow? You say no. So the computer says you have a hamster. No, dude, I have a dog. Okay, and this continues until you have a bigger tree with more information. So then, without that example, can you tell us what the process is next? What do you use the trees for?
The decision trees is the most popular classification algorithm. So you use it for discrete target variables, probably also discrete input variables. So you can use it in any kind of classification, like you have shown. Of course, you can have multi-class target variable, and it works extremely well when input data comes from people. Because our decisions are typically quite following this this quite simple process. We are not doing a lot of non-linear transformations in our minds, right? We are following this. Do I have enough money? Yes, no. Is it on sale? Yes, no. Is it the color appropriate? Yes, no. We are usually following these patterns. So that's why, as I said, decision trees are extremely useful. Even the name tells you, for following the way how we made the decision. And I don't know, I mean, if this explains, but this is probably the algorithm we can understand better than any other algorithm. That's why it is also very popular.
But it could be very complex in a quick way, right, Dejan? If we have a lot of questions, the tree can be very complex. So then we can spend a lot of time trying to get the right answer, right? So what to do then?
Well, I would say like this. We have in general it's a big difference, what I call data mining and machine learning. Data mining is usually used by people. So when we are the targets. When we want to follow the algorithm, we want to use such an algorithm that we can understand. And this is also somehow limiting the number of input variables. We are physically incapable of understanding a model with 500 input variables. And then when we do principal component analysis, which you mentioned before, we get these new principal components, which are combinations of original variables. We can understand even harder what came out. So that's why I would say like neural networks, which also do then non-linear transformations multiple times, are more useful as machine learning and artificial intelligence, while decision tree is typically an algorithm used by people. Similarly, like you mentioned, clustering, K-means can be used just to understand some groups of your customers, for example, and you don't know the labels of the groups in advance. So the model is good if you can label the groups, but you can find the label if you have like, I don't know, 10 input variables, not with 500. If you use clustering for anomaly detection, then this is more like machine learning problem. Because you just try to find those cases that do not fit well in any of the clusters. So you can afford to have 500 input variables. You can again afford to have these artificial input features, the principal components, because you don't care about understandability of the model. So this is the big difference. So decision trees with 500 input variables, I wouldn't do it in general, because decision trees is typically data mining technique used by people for people.
Yeah. Great explanation, Dejan. Yes, thank you.
Perfect. Okay, so apologies as before. We all laughed a lot with what I will consider the best scientific comment ever, but we cannot tell what it is. not online anyway. So next up, let me just mention what this is. So if you go to this website, 20q.net, this has been around since the 90s. I remember this from sometime in the 90s when I started university, sometime. And at the time, they claimed that if you had 20 questions in total, if you answer 20 questions, they would guess what you were thinking of. Okay, and this can be a cat, this can be a film, this can be a person, other objects, I don't know, something. So you can actually find it. Nowadays, it exists in a lot of different languages, but if you go to the original one in English, nowadays they ask you for 32 questions. That's because they have so much information that just asking 20 questions is not enough. And internally, and this is, I'll leave this for you for homework, because I thought about this a lot. These are some of the possible answers that do stuff to the trees, and how much crazy things they have to do to store all of this information in there. So if you are a programmer and if you understand the basic concepts of decision tree, which what we just shown before, like the cats and the dogs, etc., you can do that with 10 or 20 lines of codes and put stuff in a table. It's as simple as that. It's a very small amount of things, but for here, good luck with trying to find what the algorithm is going to be to use this, but with so much options that you show up here. So it's not a question for today, but one day we can talk about this and see the details. Okay. So next up we have so the same way you use same way you use decision trees inside of algorithms so that you can optimize and find things faster, you can also use neural networks. So who wants to volunteer to explain this to everyone on a human level?
I would say Dejan would be the best person, because he already mentioned that if you have a lot of inputs, you might not understand how the input works together. So to explain, we should have something more complex with just the regular machine learning algorithms, which means that we should use neural networks.
Okay, Dan, anything to add?
Not really. This is the point. Neural networks, artificial intelligence started very early. I mean, neural networks were already known in 80s, but they, or let's say even in 50s was already perceptron model known. It's like very simple logistic regression. But it didn't gain much popularity because we were doing this in data mining times. This was that time known as data mining, and it was hard to understand how did you get the result? And the more hidden layers you have, the more, so what you have here in this picture, like red dots are, I guess, input variables, input units, and then you combine all of them multiple times with a weighted sum to get a single value, multiple single values. The orange dots are hidden layers. And then you apply non-linear transformation. I think in hidden layer, it's hyperbolic tangent transformation.
Yeah,
and then you combine them again into output layer, and then another non-linear transformation, logistic regression. So it's practically impossible to follow this pattern, right? And that's why they were not so popular in 80s, 90s, but they started to gain popularity when people realized that we can use these algorithms also in such a way that we don't really understand exactly what they did inside to get the value, as long as predictions are good. And they are very good, better than decision trees for modeling associations that are not linear. Remember, decision trees is good for linear associations.
So perfect. Okay. So we're almost at the end of talking about the algorithms and stuff and starting to do the actual demos. So, but for now, let me just mention one last thing that you should know about machine learning, which is when you have any kind of AI or machine learning models and you are predicting things, if your result is like Damien said, oh, you get 100% of the results, you're probably doing an if kind of thing, like an if tree or something like that. So it's going to be very predictable. That's probably not what you want. Okay, it's like doing a SQL query. That's probably not what you want. What you want is something that never reaches 100%, because otherwise it's probably not going to be machine learning, but that can actually have some intelligence behind it. And as Dan just said, sometimes even the most basic models that you generate out of this, you feel that they are predictable. You feel that you know what they are expected to do, but then at the same time, sometimes the actual machine learning training, which is very abstract without social constraints or anything like that, that social training will actually reveal a completely different logic. Okay, an example of that is one that's very simple. So for instance, my niece, when she was like 2 or 3 years old, I asked her a very simple question. Okay, why do people get divorced? And that's a very simple question. You ask a kid, you get a very innocent answer. And most adults that I've asked this question, if this was in person in a training or in a conference, most of them would say, oh yeah, they don't like each other, or it's a money problem, or they found someone else, or I don't know, those kind of things. A child will say, oh, they get divorced because they got married. And guess what? That's the real reason, okay? 100% of times, because if you look at, a state machine that says, oh, you are born, you get married, you get divorced, you die, etc., and then some cycles around if you are crazy and, those kind of things, the previous state before getting divorced can only be getting married 100% of the time. So for a computer, this is very obvious. There was no social constraint here, and they will find it. So for a computer, ignoring the social constraints actually helps a lot to get an answer, which in some cases might make more sense, other cases doesn't. Okay, but well, that's another story. Okay, it's just a quick reference, and I have no place to be here that doesn't affect anything. So we have a regression here. By the way, this is the aka.ms/ml cheat sheets. Okay, so if you go here, this will go into GitHub somewhere, and you get, or docs.microsoft.com, whatever. So you get to see this thing in the most updated version, which might not be this one when you see this video. So just get the most recent version, which is best. So regression is here. So anything regression, so linear regression, very fast training linear model. So if you have twice the data, you spend twice the time and twice the memory at most, okay? However, you have others that say fast training times, long training times, others that say large memory footprints, so that becomes exponential. When you have more data, you require exponentially more, RAM memory, and depends. This one says fast training time, so the CPU is not a problem, but in other cases, long training times, maybe the training time becomes exponential. So this is actually good as a cheat sheet so that you can find out which algorithms are better for you. The correct answer to find which algorithm you need to use. So let's say, first of all, you need to decide, do you want regression? Do you want like yes or no kind of two-class thing? Do you want multi-class? So you get to decide, first of all, the category that you need out of all of this. And then from all of these, one of the best solutions is run all of them. I'm not kidding, but run all of them. If that seems obvious, you can exclude a few of them that you might feel that they make no sense. But in the end, the easiest way, if you know nothing about this, run all of them a bit, see which ones behave better in terms of quality, and then train a bit more with them, and then do hyperdrive training with this. So basically tune hyperparameters with a lot of different hyperparameter combinations. If you use Azure ML, you can use something called hyperdrive, which is the technology to run a lot of them, a lot of trainings at the same time. So you can use that one. But if it's any of the other ones you choose, so you have multi-class, two-class, stuff for image classification, also stuff for text analytics, stuff for recommenders and clustering and anomaly detection. So much that you can do, and start somewhere, have some fun, start somewhere. If you are a data person, you're probably going to use a regression or two-class classification. Sometimes you need others. As Katalin rightly mentioned, if you do need to use image classification or text analytics, you probably want to go to cognitive services to have a look, okay? This is the one that you want to do, okay? So having said this, let's move on and we'll do some quick demos. Okay, so if you are a human, any human can do this if you have a basic of, I don't know, a bit of programming, data management, etc. You can do this, so we'll give it a try. Okay, so let's do some quick demos. And last but not least, and I have no place to hide away to, so I'm going to be here, just my hair or whatever's left of it, and just give you a list, and then pause the video later on and have a look at this list. This is a complete, not complete, but it's a reasonable list of all of the ways you can do machine learning in Azure specifically and in Microsoft. So the Azure Machine Learning SDK, you have the service and workspace, but you also have the classic. So this one, I'm actually talking about the service, but you also have the classic one as well. So still works, very good. You have Azure Databricks, which runs Spark clusters, same as HD inside with Spark, same as Synapse Analytics, where you can run Spark as well. And Spark can run inside using a lot of different languages. So you can run in Python, R, Scala, in .NET here as well if you're using Synapse, which is nice. R is complicated here, so let's not go there. But you can also do coding using SQL. So if you want to clean up your data using SQL, that's a way. Okay, so if you prefer SQL over Python, that's a way. By the way, you don't have to know Python or R or Scala. The magic is in the libraries, and in most cases, you just have to do copy pastes to some lines of codes. Most trainings you can do with 2 or 3 lines of codes. Just copy paste the thing, change the basics. If you are a developer, you know how to do this, okay, and you can get this working, okay. And we'll show you 1 or 2 examples of how this is done. And yesterday we had Marcin show us how to do this with codes. We'll skip that, some of that part. We'll show you just the basics, but we'll show you some nice other alternatives to get started. So anyway, you can also do cognitive services. So Katalin was mentioning cognitive services here, really nice. You can do bots if you want to, or Power Virtual Agents, which is bots, but done in a managed way. But you can do a lot of different things here, even using SQL Server with some of these services. You can do it with code in your computer. Let's move on to interesting things. Have a look at the list later, and let's have a look at the demos. So let me just go for this to a corner to see if this works. Let's go for a demo. Okay, so now I have this is not moving away. So I have my Azure portal. If you don't have an Azure subscription, and by the way, some of the things we'll show you can actually just do in Python. You don't really have to have an Azure Machine Learning workspace. But if you do, this is nice, okay? So you can go to azure.com/free to get free stuff. So I'll actually do that for a bit, very, very quickly. If you are a student, this will help. Azure.com/free. So you get free stuff, okay, for 30 days and credit, whatever. If you add students here, sorry about that. Students doing this thing live. So students, if you get students, if you are a student with your university account, You can get this for free as well. So it's less, but it's money. So it's the best you can get. Okay. So Damien, let's attack this. So let's create, very quickly create a machine learning workspace. By the way, I already have one created. It's just pretending to create it. Machine learning.
Oh, still some, yep.
Machine learning. Okay, sorry about that. I'm writing here and seeing there. Okay, so I have machine learning. You make sure it's Microsoft, and then you say create. Okay, and then you answer a few questions, right? So this is easy. Anything specific that we need to care about? Not much, right? Just give it a name. Yeah, just give it a name, put it in, pay for the subscription. This is how you need to know where it is. Give it some resource group, give it a workspace name, the location where you want it. And all of the rest is easy. Just let the defaults. Next time you use it for a professional level, maybe you configure it yourself. But when you get started, say the defaults. So let's say I'm just going to say X here, a lot of X's, and suddenly all of this is filled with X's, so it's fine. Networking, just use the defaults. Advanced, use defaults. I'm not going to talk about security today. Just going to say create. Yes, stuff is missing. Let's pretend that I click, it works fine. And then let's have a look at the result, which is, I actually have this here. So I have the machine learning workspace already created. And we go here and we have a machine learning workspace. What's the only thing we need to know? Well, in all of these services like Azure Machine Learning, Synapse Analytics, Databricks, etc., all of this stuff is usually useless. What you want is to press the button. Okay, so we're pressing a button. Seems very intuitive so far, right? But before you find the button, if you have a small screen, now that's the difficult part. Okay, so let's ignore most of this, and we have interesting things. So Damien, let's talk about computes. Very quickly talk about computes.
Quickly. So we have compute instances. So I treat compute instances like I could tell it's like my development machine where I can have all the necessary applications like Jupyter notebooks or Visual Studio Code, or if I would like to use the communication through terminal, I can have it. So the case is here that you can during the configuration of this virtual machine. You should decide how big the virtual machine should be. So you can say, I would like to have a bigger or smaller machine. Do I need to have a support of GPU? So everything is there on the configuration. What you have to remember is that you have to basically make sure that you stop the virtual machine after you are done, because this compute instance will be up and running forever. And you will be paying the cost which is described on the right-hand side. So this is actually something that you have to be aware. So if you choose there is enable idle shutdown.
It's new. It is new.
It is new because it was not there, I would say, before vacations. I think it was not there. So, but I think people were complaining a lot. Yeah.
So there's some setting here that you have to enable preview features or something like that.
Oh, okay.
I don't know, but I enable them and it's there. So it's something like that. Yeah. I'm not sure. But this is useful. To be honest, this is very useful. So yeah. Yes. By the way, I started the machine by now. So this is starting. If we need to use
so I still have time to go to compute clusters. So the compute cluster means that you can build a cluster like you imagine that, like a Databricks cluster, something like this, or the cluster in Synapse, where you can say, okay, if I have a lot of data and need more compute power, so the laptop or the virtual machine I created as a compute, the compute is not enough. So maybe I would like to train my model on a bigger cluster because I would like to, for example, as we said previously, check all the possible algorithms and check their quality. So we'd like to make the operation in parallel, right? So you can define how the cluster is built. You can define what is the minimum size of the cluster, what is the maximum size. So the cluster will scale up and down accordingly. And of course, there is a setting which I love very much, which says idle second before scale down, which saves you a lot of money. But in the other hand, if you think about it from the production perspective, then this is I think 120 seconds, which is 2 minutes, is not enough because on the production, you may have the entire pipeline. So the cluster will go down and it will be called back again, and you will be waiting for it to wake it up, which can be 5 or maybe more even minutes. So it's you have to have the balance about wasting money and spinning the cluster back again.
Exactly.
Yep.
By the way, just to mention, this is not good for a demo because I can have a maximum of 1 node because I have a limited quota, but I usually have bigger, like 5, 6, 7, etc. It's the normal you might get here, but I'm very limited in the subscription that I have
So
today.
in that case, if André says I have 5 nodes, each of them has 4 cores, I don't know, 14 gigabytes of RAM, so 6 cores, sorry, 4 cores, 14 megabytes of RAM, and this number of storage. So you can imagine that if you have 6 nodes on this size, they can do a lot of work, right, for you. So, so it's a pretty big cluster, and it could be bigger. You can have even GPU cluster support. Yep. Then we have inference cluster. Yeah.
The other ones are bigger.
Yeah. So we have inference cluster. So that's basically when you have your model and you would like to deploy it. So then you deploy it to the containers. Make the story short. But you can imagine that I have already a cluster. Yep. So this is how you create the model. But you can automate the process, so you don't have to do anything manually here. But the last part is very interesting. So imagine that you already have your cluster and you would like to host your model there. So you can choose, for example, okay, I have my Databricks. So maybe I can attach it here. So this is the way how it could work for you. So you have, I think, all possible options and configurations. Just choose the one it works. So I think the Databricks option is very important here because a lot of people have Databricks clusters with their model and data processing already there, and they would like to attach them to the ML workspace. So this is how it works.
Perfect. So exactly. So wait a minute. Okay. These kind of things, you can definitely use them in a lot of different environments. Synapse, for instance, is the next future. I'm assuming that sometime in the future, this machine learning studio and Synapse will probably join together.
Yep.
I keep expecting this, but it will be eventual. I'm not sure when. Okay. We have. Oh, sorry about this. Okay, it keeps jumping into the scary face. Maybe it's the robots taking over. Skynet is taking over. Anyway, we have data stores. Data stores are just sources of data, okay? It's like you store a connection string to point to the right place, like a SQL database. Let me just show what's available. So SQL, Postgres, MySQL, MariaDB, etc., and storage accounts and file shares. This is basic, right? But the actual data, if you have an actual table or data set, if you want to be formal about it, that actually shows up here. So it comes from a data store and it shows up here in data. And in my case, I have a sample diabetes. That's the one that I have, right? Okay, so you can have a look at this. So we'll try to use this for example, okay? So this one is actually very simple. Consume, I really don't want to, well, if you want to consume it, you can actually use code for this. So you can literally use this code to actually consume this in a notebook or something like that. In terms of exploring, I can actually explore what's here, number of columns. This is just an example. So the X columns are usually inputs, Y columns are usually outputs. In this case, the output is, do you have diabetes, yes or no? Not a yes or a no, but if it is within a certain range, you are okay. If you are outside of a certain range, you are not okay. So age, gender, body mass index. So basically saying that I'm fat, pretty much, blood pressure, and then all of the S's and stuff like that, which I have no idea what they are. But the objective here is to try to calculate the Y, to predict the Y, to predict it based on the information you have. Are you more likely to have diabetes or not? That's the expectation. And let's try to run this. Make sense? Let's try to run this. By the way, spoiler alert, don't worry, it's already run. It takes like 45 minutes. So we'll do this like a cooking show where we pretend to do it and then we take it out of the oven immediately. Okay, so don't worry. So first of all, where did I get that diabetes data set? I went here to open data sets, okay? So sample diabetes, and then you click on next, you create it, and it's done, okay? Take my word for this, this is where I got it. and then you select it, click on next, and now you have the 3 types, right? Oh, wait a minute, I have to do bureaucracy first. So create a new experiment. So diabetes experiment 2, I already have one. Target column can only be the Y, no? That's our output. And then compute cluster, where do you send this? Oh, if it is an instance, I can use that one that's actually running. Or if you want the cluster, I can actually have 2 clusters at this moment, okay? This one was created by me. This was created by a script that you have somewhere in codes, okay? But both of them work, okay? So you select one, and then you click on next, and then you select the types. And we talked about the types, right? So Damien, anything to add to these extras? Do you want to talk about any of these extras?
Yep. So, you know, we spoke about these processes. You described the process at how the machine learning process looks like. At some point, we were able to define, for example, some settings. So when we are satisfied and the model is good enough, we can stop. So if you could open the other link first, and then we go to features.
The other one, okay.
Yep. So then you can say, okay, if we do classification, this is actually for regression, if I see, right?
This is regression. This is regression.
This is regression. So you have to have a metric which you choose, and then if the metric is satisfied, so if the number is good, so you can say, for example, the error, in that case, the normalized root mean squared error is on some specific level, should be very, very tiny. So if this condition is met, then you say, okay, my model is good. But then you have a good if you close it, then you can perform information. So please explain me the model. So what features actually what of the features is very important from the model, has the biggest weight, so the biggest influence of the model. Then you can choose the information. Then you can choose, for example, models or algorithms you don't want to use, because, for example, from previous experiments, you know that some of them are just not working very well for you. So why should we spend time? You can just exclude some of them. And then what I'd like very much is the exit criteria, which means that you decide when the processing should stop. So you can have different constraints. For example, you can say you have half an hour of training or 1 hour of training, and then you stop. Or you met the specific criteria on the primary metrics. So you decide the number which should be met, some threshold. If you met the number, the job will stop, the experiment will stop. And then you have concurrency, which means that if you have a cluster, so then in that case, you can parallelize the operations on all nodes, so have the results quicker in that case, right? So this is, let's say a technical configuration. But then we can say that if this is automated machine learning process, so if you can close it, then we can go to features. Or if you have a comment here, no? So
no.
This is all features.
Please continue.
So then we can choose. If we would like to use this feature, we have the data type. We can specify it, and for example, we can say, okay, maybe this column is not important, so maybe we can remove it from the model. But this require a bit of knowledge. So it was said that at some point, if you see only data, it's not enough. You have to be able to also have the meaning of the data. So, for example, in that case, I assume there should be some kind of expert sitting nearby you, explaining you how, for example, age influencing the model. And then the column with the information which Andy already expanded, which says impute with. So imagine you have a bunch of data and some information of them, it's null, right? So you perform a measurement, but for some reason the value was null. So how you would like to change the null into something meaningful? So in that case, you can say, okay, I will take the mean value of the entire data set and change the null into mean value. But then I would say, okay, but is it right? Do you know what you are actually doing? Because maybe the safest way will be to remove the entire row. Exactly. So that's why you need to have an expert that the expert has to say, you can impute a new value instead of null. So this is how it works, right? So it's not an easy answer here, and it's very case sensitive to a case you are trying to solve. In that case,
it's never replacing nulls with zeros. That's usually never
nulls with zero. No.
That's usually never the answer, but it will depend on a lot of circumstances. But I agree with you. With some cases, removing the whole row altogether makes the best sense. But depends. Okay. So anyway, once you do all of this, cancel yes. By the way, some featureization can be done automatically. So if you don't touch it, they do things. So it's not our problem, they do things. So you click on next, and then you have validation. So we talked about cross-validation, etc. So this is where you do it. I'm not sure if you want to bring something up on this one.
No, I don't think it's important. We just have different options for validation type. Do we have our own data set, or we would like to create a testing data set here? So in that case, we can provide the information. So it's technical thing.
Okay, so let's click on finish, or pretend to click on finish, and let's see the results products. Okay.
So if you click finish, then actually the experiment is going to start. So if you have a cluster, the cluster will wake up, and the code will be deployed, and the experiment starts, and we can go for a coffee because it takes 1 hour, as you see on the previous one. And within an hour, we'll see what really happened.
No, it was 1 hour, yeah. It's usually 45 minutes. This time it was bigger. It's usually, when I run this exact one, it's usually 45 minutes. But anyway, here's the results, okay? Let's go here for the details of this. So when you ran AutoML, and this is AutoML, what this happens is that they will try to train a lot of different, do a lot of different trainings with different hyperparameters, with different algorithms even, okay, and try to get all of these results to see what's best. And then they have some metrics. So metrics will be here in the details somewhere, but you choose the best metric out of all of this, okay? So I'm going to go to some of these, which are probably going to be the correct one. And let's have a look at the metrics. So you have some metrics, okay? So we can actually have a look at all of this. So there's actually, give me a second. So diabetes 1, I am in the right place. Include child jobs, okay? And we were doing mean root squared error, right? So normalized mean squared error, exactly. So I can select all of the childs of the process, so all of the individual trainings that you did, and get them graphically. So yesterday, Marcin was actually showing a lot of results that look like this. You can create more graphics like this as much as you want, but basically you are getting results. So great fork is this one. So which one? So the last one. So the last one seems to be very good, apparently. It's very low in normalized mean root squared error. So maybe this is the one. Seems like a big distance, doesn't it?
It is, yes.
Yeah, feels strange, doesn't it? Yeah. And this one is very high. So Sperman correlation is very high. So maybe it's a really good one. Or simply, it's good because it used a different model altogether that worked well. I don't know, something a different algorithm that worked well. I don't know, something like that. Okay. So anyway, let's say that we decide to use this. So how do you use this? Well, first of all, you can say + register model, and that will actually save the model into the list of models here. So if you were doing machine learning with Python by code, etc., you would have to save it in a file on disk, etc. Here you can just click on a button and jump into the models. When you have them in the models, that's even better because you can do deployment of web services and other things. Let me just show 1 or 2 more things. So you have a lot of things like while you're running the training, maybe you would generate images with situations like you do the matplotlib and other libraries in Python or something, and you want to see images of the current status of things. So you can generate images here. Child jobs, of course, outputs. All of the code gets generated and shows up here. You can see it, and the results, all of the blah, blah, blah results that you have them, you can actually see them here. Technically, all of these is in a storage account. So if you don't see everything here, the storage account will be more complete. But in most cases, what you have here is more than enough, okay? So let's go for models. And I do have different models, but let's pretend that these were the right ones. I can actually select one of these. Doesn't really matter what this is. This is for a completely different training. And then I can say deploy. And I can deploy to using a web service, or a real-time endpoint, which technically might not be that much different. So a web service can be a cluster, a container, or put it in a Kubernetes cluster or something like that. Real-time endpoint might be a virtual machine, something, I don't know. This is actually very flexible here, okay? And batch endpoint is something where you, on, let's say, once a day or something, you run something that uses that information. So you run some code, still some pipelining as well, but typically with code. And then you process the data, but in batch. Instead of doing one by one, you do it in batch. And we mentioned this before, so responsible AI, fairness, explanations about which features are more important and less important than others. So we have all of this here, and the Azure Machine Learning SDK does all of this for us. So Damien, I'm not sure, but let me give you my advice, and then you suggest maybe a different advice. But my advice is, if you want to do AutoML, this is the best place to get started. Try to understand some of these concepts, try to understand these extras like explanations, fairness, responsible AI, etc. And then once you get the hang of this, go to the next ones like the designer and the notebooks. Yep. Does this make sense?
Yes, and I can tell you that I use automated ML anytime I want to quickly verify hypothesis, right? I would like to prove or falsify the hypothesis without going into much detail, spending time on coding, because why should I spend the time? I have a data set. I know what the data set should do, what the prediction should be. And then let's quickly verify the hypothesis. By the way, automated ML, as far as I remember, you can only do supervised machine learning. So if you have something unsupervised, you cannot go this way. But for the supervised machine learning, you can do. Unsupervised, you can go to notebooks, and in notebooks you can do whatever you want, right? But you have to be a little bit more skilled developer. In Designer, you can design the process like you've seen on the slides, and you can have a lot of examples here. So you are not starting from scratch. You can just take a look how, for example, yeah, it's an example.
This one is good. Yeah.
Yeah.
So,
of the trees.
Preview data. So this is actually a good one to start. So you have things like data regarding a group of people, 32,000 people, and then in the end they have the income bigger or less than a certain value. For instance, this could be used to predict a bank loan, if this was okay for a bank loan. All of the concept is the same, although the objective of the data set is not exactly that, but think of this as predicting if you are allowed to have a bank loan or not. Okay, so most would say no here, but some of them might say yes because they receive more money or something, but possibly slightly different other values. Okay, so you can actually train this. And Damien, we were talking about this before, splitting the data. Sorry about the format being so ugly. Splitting the data, and then continue on filter-based feature selection, so you can clean up and decide on just 5 features in this case. This is what you were talking about before. And then finally, you can actually do the actual training. So there's a nice box to say simply train model, one training, okay? But you also have the tune model hyperparameter box, which you can train a lot of them at the same time. So basically the equivalent of hyperdrive if you use code. Anyway, you score the model, evaluate the model, the rest on the right, let's ignore it for now, and then you get the result out. Once you submit it, and we're not going to do that now, but once you submit it, you then get a button here to say, okay, publish it. So you publish that, you publish the model here in the model list, etc. And then you can actually deploy a real-time inferencing endpoint so that you can create a web service based on this, okay? Now, the endpoints that I have here, let's go for that endpoint, by the way, because I haven't shown this yet. And this has been a very long session, so let's not take that much time from everyone, but this has been a very good session, so very good inputs. So for instance, here, you can actually add some data. Usually this might be a JSON
document. Yep.
The reason this does not work is this sklearn nest is actually a list of images. So these are images, that handwritten images that you can predict if what they are written, etc. So like digits that you can predict for OCR. That's why it's empty. But let's say it's that data set we saw with the age, with all of that. You can open up a JSON object and say field 1, field 2, field 3, get the values, click on test, and then you get the result out. But sadly, maybe next time we'll get some results. But try this yourself. You'll find this very intuitive, just clicking a button, and you suddenly have, in this case, it's using Azure container instances, not Kubernetes. It's just one single container floating around in the cloud. Yes, we are paying for it, but then in the end, you can turn it off at any time. Anyway, last but not least, let's check out the notebooks. Do you have a preference? So by the way, this is the one that I was creating that thing for. Run this one and run this one, and you'll be very fun about this. Okay, let me just show you the results. Let me shrink this. It says notebooks here. So I'm on notebooks here at the top. Makes sense. So if you run all of this, you'll see that you just leaned a few lines of codes to use the Azure Machine Learning SDK, which is an amazing way for you to orchestrate this, to do MLOps, in fact, okay? So all you have to do here is, this is how you create a cluster. Pretty much, if you already have a cluster, oh, that's fine, just use it. If you don't have a cluster, let's provision a new cluster, size, minimum, maximum, the things Damien was talking about. And then here we go, please create. 2 lines of code. How hard is that? You do it right because you add some variables to it, but you can be lazy and just put it all together in one line if you want to. Don't. So anyway, you create the cluster. All of that is very quick, and then you play around with data. This is the data cleanup stuff someone mentioned before in the chat. You should use clean with uppercase. Yes, I agree. So you take the data. You can see the data, so you're actually plotting the data. These are the digits, these are the labels, so the result, the Y result that you want to predict. And then all you have to do is to do the training. This is a script for the training with some hyperparameters here, and then some data going in, and then the actual training is just this. This is literally just the training, selecting the algorithm and getting the training done. How hard is this? The algorithm has all of the hyperparameters here. So whatever they are, and then fits clf.fit, classifier.fits, and that's it. By the way, this is multi-class classification because you get the results from 0 to 10, so 0 to 9, 10 possible results. Okay, and then how do you do the? And this is the same that we saw graphically, right? So this is the training part. This is the scoring part. So you're going to predict, but based on the testing data set. So the other part of the data sets, and then here. This is just a simple 1 line of code to compare the prediction with the real results. And this is all you have to do. This feels strange for someone who's doing things like C#, but this is actually very basic operation with these data sets. It's very basic, and you compare the two and get the result out. So accuracy is, and then the result will be somewhere, it's actually down there. But then this run.log actually puts all of the information like accuracy, all of these metrics, they put the information here where you can consult them. So this is the magic that generates run dots, and then you can generate an image, you can generate a table, you can see all of the results out and actually document all of the results, which is great. So to run the training, very easy. So you set up the environment, specify what kind of libraries you want, etc. And then all you have to do is to run it, specify in what kind of machine do you want to run it, what kind of environment, etc., what kind of scripts, and you are ready to submit it. Experiment.submit, done. And then this runs for a while, and then you can actually monitor it on the other side while it's running, but then you get results with some widgets, which are nice, but then the result is done. Okay, so this is actually very, very quick. Okay, so let's jump out of this one for now. And then you get the metrics. So accuracy, 91%, really good, okay? And then register the model. So to register the model there, you just say run.register model. How difficult is that? Instead of actually storing things, writing in a database, whatever, this is just much faster. Okay, last steps so that you can create the actual web service, a long session, sorry. So this one, they register the model again. That's why I have 2 there. But then you have some environment again. This environment does not have to be the same as the training. It can be much simpler because here you're just doing predictions. So it can be much simpler. That's why you have here Azure ML defaults. okay? Because you just need the default. You don't need a lot of things. You need pandas, data frames, you need views, but you don't need that much more, okay? And then this is the actual environment. By the way, you can go here to environments here and actually see them graphically and actually see what's there, so you can decide directly. And then you set up things, blah, 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 deploys web service. So you set up the scoring script. So you create a file that looks like this. And then the init is to initialize things, right? So you initialize, get the model from wherever the model is, and then run. Raw data is your input in JSON, typically in JSON, from your web service. And then how do you predict things? One line of code. How hard is that, right? Makes sense, right? Okay, so last but not least, you need to deploy the actual thing. ACI, that's Azure Container Instances. You need to deploy them, and you say deploy configuration, certain sizes. The rest is bureaucracy. You don't need this, okay? And then you deploy the thing. And the only trick that I did here in the part number 2 here is that here, well, you can get the results. At the very end, I commented the thing that said, delete the service, okay? Because I wanted to keep the service after this ran, and this ran during the night, so I didn't want to wake up for this. So anyway, you can try out the results. So let's try out the results, predict with the test data, etc. And the results will look something like this. So predictions, on the left is real, on the top is prediction, or vice versa, I'm not sure. And the center one, because you have 91% accuracy in this, 91% should be mostly in the middle diagonal. Now, the trick here is that you get rid of the middle diagonal, and you focus on the other ones. So it's in fact number 5. You can see this is all you need to do to see that thing graphically. How hard is that? It's very easy to do. And you can copy paste this. So this is very easy, okay? So last but not least, you try to do predictions. This is probably the first one where I only have one error. So this is actually quite good. It's not deliberate. And then you clean up the resources like service.delete, or you just go there and delete services here. You can just, okay? So Damien, sorry about this quick sequence of events, but what I want to ask you is, do you recommend anything in these samples that people should look at first?
Oh, you should start with something which is kind of the model or the process you can understand. Mm-hmm. And I think that the example you have shown in classification, the handwriting, especially the numbers from 0 to 9, is something we can understand because we know the numbers. So we are experts already, right? We know what should we expect. So we should start with something which is simple. And there are a lot of examples delivered by Microsoft. But I would start something simple. And I already, that was one of the first examples when I learned this was about the data classification, because you don't need an extra knowledge, let's say expert knowledge on that area. It's just simple case.
Correct. So you have a lot of examples here. Let me just add one more, which is actually very linear to learn this. So if you go for, it's actually this one here. Sorry about this, I'm in the way. So if you go here for DP100, so I'll put up the link so that
DP100, yeah.
And this is an amazing set of labs that you can do in a sequence. It's one of the best courses I've seen. You can do it in a sequence and actually learn this from beginning to end with all of the amazing things. So it's not this one. It's the one in English, but it's not that one. So maybe it's down here. So we need just search for it, but it's the one that says English. So this one, public.
This one, yeah.
With recent updates. So this is the one. Okay, so I'm gonna put the link here. Just freeze the video. Go to this one, and you have instructions here, and instructions, these are very sequential, right? Very sequential. So do this all in a sequence. You have the data drift stuff that's Ben was talking about. So really, really nice. But you have tuning hyperparameters, doing AutoML. So yesterday we had Marcin do AutoML with code, with actual codes. You also have AutoML, but with the graphical. You have the designer as well. So you have all of the things, but most of it will be codes. Okay, so please experiment with this in a sequence. That will be great. And you learn all you need to do with this one. So this is actually quite fun. Okay, and yes, we are finishing now, but let's leave this off to anyone else who is here with us. So Dan, Katalin, everyone, would you like to say something about these kind of crazy things? Just to finish up. I'm not sure if there's any final questions, but I don't think so, at least not on the list. So crazy, a 1 hour session turns into 2 hours, but that's okay. It was really good to have everyone's comments. So Dan, final words.
Well, I think we used enough time, so I don't think it makes sense to add anything to this presentation. I guess it was great, and that's it.
Okay, so Katalin.
Yeah, it was a
continue.
Yeah, it was a long session, so we didn't have such long sessions before, but looks like this one covers data science from scratch, describing regressions, describing the evaluation, etc. So it was cool, but I'm pretty sure that it's very useful for people to learn things. And Katalin, sorry for interrupting you. I guess it was your turn.
So I learned a lot. It was a very nice presentation. But to get back to Bogdan, so please do not forget to subscribe and click also the bell button for notification, because on YouTube, because there is a lot of interesting content following. So
yeah,
I pay you back for intro.
Yeah, so I see we mostly see people in LinkedIn coming. So if you are in LinkedIn coming watching our streams, so don't hesitate to click on YouTube button and press notify for our next sessions. So that's it on my side. I don't want to interrupt you anymore. So Taras or anyone else, Dayan, Ricardo, your turn. If you want to say a few words, you're welcomed.
So Damien, Taras, Damien, anyone?
Yeah, I just want to say that. Sorry,
go on.
please.
Okay, so I will tell one word. So thank you. Here it's always a great experience if we could share the knowledge and also learn. Yeah, in the situation it will be possible, and the world will be calmer, and we will not be talking about the war, but we will be planning next conferences to see all of you together in one place, which we really would like to have.
Thank you, guys. I guess with this kind of support, what we have right now, we definitely will have this opportunity. And just a last sentence from my side: do not forget about the donation. Yeah, we are going to support our Ukrainian army, and specifically with the copter. So thank you all. It was nice to having you in this place, and wow, this is a really great conversation today.
Thank you very much.
So thank you everyone for being here, and yes, 2 hours of video, but hopefully you'll find this very useful. For everyone who participated in this, thank you all very much. This was really nice to have the feedback from everyone and make a constructive video that anyone can learn machine learning from. And especially, I want to say diakuyu to everyone. So thank you very much to everyone. And I hope to be able to say those same words, but in person next time in Ukraine. Okay, thank you all very much. See you tomorrow, in fact, for
and don't forget now
we want to guarantee that Ukraine is rebuilt and back to normal. So everyone is trying to help in any way that they can, and this is one way you can help. So please help. This is making a difference. Okay, thank you very much, everyone.
Even smallest help is important. Even the smallest help is important. So let's do whatever we can.
Thank you for your help. Thank you for coming.
Thank you.
Have a nice evening.
Thank you very much.
That's
Nice.
fine.
Thank you.
Bye.
Bye.
And see you again.